In this video, I will show you how to check the given number is prime or not. First, we will check the definition of the prime number. If a number is successfully divisible by only 1 and itself, then that number is declared as prime number. So using this definition, we are trying to implement a logic to check the given number is prime or not. First, we will open a new source file, include the required library files, that is standard input output header file. Begin the main function. So we are going to collect an input number from the user, so that I am declared as n, and I want to check that number is divisible by how many numbers. So for that I want to maintain a count. Initially I said the count is 0. If the count is exactly 2, 2 means if a number is successfully divisible by 1 and itself. If count is exactly 2, then only I declare that the given number is prime number. Otherwise, I can conclude that the given number is not a prime number. And I want to iterate a loop n number of times beginning from 1. Suppose if I want to test 7 is a prime number or not. So how can I test? So we need to start the journey of the division operation to check the remainder, that is with modulus operation. 7 modulus 1, 7 modulus 2, 3, 4, 5, 6, 7. So if you want to test 7 is a prime number or not, we have to start capturing the remainder value beginning from 1 to up to 7. So we need to repeat the loop beginning from 1 up to the given number. So for that I need to maintain a loop. So for that I need a loop control variable I. So in future if any variables are required, we will again come back to this line and we will declare some more variables based on our requirement. So we need to provide a message to the end user who are going to use our application. We are collecting an input value, enter a number. And next one is we need to collect that input value. As it is an integer, use the format specifier as %d and collect the input value using ampersand n. After collecting the input value, first we need to iterate a loop beginning from 1 up to the given number, that is called n, and each time the loop control variable is incremented by 1. So here we need to include the logic. So the purpose of this loop is to check, to apply modulus operation beginning from 1 up to the given number. So here we need to test, is that number, entire number is successfully divisible by I or not. If it is successfully divisible, immediately we need to increment the count value. Immediately we need to increment the count value. So we will check this remainder operation. We will check the remainder. We will check the remainder value beginning from 1. Initially in the first iteration I value is 1. The last iteration I value is n. So 1 to n it will check. If the count is exactly mapped with 2, that means after come out of the loop, we need to test is the count value is exactly 2 or not. If it is exactly 2, then we can conclude that given number %d is prime. So this number is represents n. This %d is represents n. Otherwise, we will provide a message the given number is not a prime number. This given number is not prime. So finally we close the main function. So we need to save this program. This is a demo program about testing prime number or not. So prime demo 1.c. Compile this program to check syntax errors. So no errors, no and no warnings. So we can run this application to check the output. So enter a number. Suppose first I entered 7. So given number is 7 is prime or prime. I will test one more number. I will rerun the program. This time I will enter some 4. How many factors are there for 4? it is successfully divisible by 1, it is also successfully divisible by 2, it is also successfully divisible by 4. That means the 4 is successfully divisible by more than two numbers. So we can declare that this is not a prime number. Given number 4 is not a prime number. So we tested both the cases. If you want, you can test for one more number. Suppose uh, 13. So 13 is a number. This is successfully divisible by 1 and itself. It cannot be divisible by 2. It cannot be divisible by 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it also divisible by 13. So that means if a number is successfully divisible by 1 and itself, then only we can call it as a prime number. So given number 13 is a prime number. Suppose if I given 14. This time if I given 14. 14 is successfully divisible by 1 and also divisible by 2. So and also divisible by 4. That means more than 2 are available. If the count is more than 2, then we can declare that it is not a prime number. Like this, we can check the given number is prime number or not. So if you observe here, this I will explain this step. This for loop is to read to read 1 to n, and this n modulus I is checking. Suppose if my entered input value is, for example, if my entered input value is 7, in first iteration my I value is 1, in next iteration my I value is 2, in next iteration my I value is 3, and so on. After some iterations my I value is 7. Up to 7 only it will test. Why? Because we kept the condition I is less than or equals to n. I starts from 1 up to 7 only it will. Once it is becomes 8, then this condition becomes false. It will come out of the loop. But in each iteration it is testing whether the returned value is the remainder value is 0 or not. If it returns 0 means what it indicates, that number is successfully divisible by that particular I value. That particular I value. If it is successfully divisible, immediately we are incrementing the count value. Initially the count value is 0. We set the count value is 0, and after come out of the loop, how many times it is successfully divisible from 1 to up to the given number. So here n value is we entered as 7. Now once it come out of the loop, it is exactly contains the value 2. That indicates that the number is successfully divisible by 1 and itself. Then it is called as prime number. Otherwise it is called as not a prime number. So like this we can test the given number is prime number or not.